Hello everyone. This is a presentation and a demonstration of a project named EzCall that I have been working on. There is a paper that talks about all the architecture and implementation details about it. But the basic idea is to create a very lightweight call signaling and use peer-to-peer conference control for a multi-party video conferencing using WebRTC. The paper has all the details, architecture, implementations, tricks, and so on. Here, I'm going to show the demonstration. EzCall is basically a web app, but you can install it as a browser extension also, or as an installed application on desktop or mobile using Progressive Web Application, PWA. So for example, this is the web app. You can click on this to install it locally on the desktop, and same thing for mobile.
So for the web application, make sure that these four permissions are allowed: notifications, pop-ups, camera and microphone, especially if your browser default is to disable those permissions.
I have also installed it as a browser extension here. This one is logged in as my email address, and I have used some dummy login address for this. So there are two instances of EzCall on this browser, one as a browser extension and one as this. You can, unlike many of the other video conferencing system, you can do a self-call test. So you can just call yourself here, and that will allow you to test if this thing is working now or not. But here what I'm going to do is I'm going to call from the browser extension to this web application, and this is the optional topic, and let's see what happens. So both the caller and the callee side receive a notification. On the caller side, you can click on it to cancel the notification. On the receiver side, you can click on it to answer it, or you can do decline by using more option here. I'm going to answer it here. Once the call is established, these two tabs belonging to the two separate users are now connected in a call. You can send a message. Hi there. This is user Carol, and the other person can type and send the message. So this part is the text chat. You can hide it up. Let me call the mobile app too. I have already installed this on my mobile phone as a PWA, and it's logged in as Bob. So instead of creating a new call, I'm going to add the mobile user in the existing call by selecting it here. Once I get a notification here for the call, I answer that, and now the three users are all connected. So let me send a text message from here, and that's from the mobile user. Let me show you the video call. I'm going to move this away and then start the video call from first user, webcam from the second user. So these two users are now in a video call, and I'm going to start the video call from the mobile also. So mobile is also on the video call. So this is my mobile phone, and that's the mobile video. There's three videos, and you can turn it over to make it, and you can double click on one of the videos to make it bigger. Okay, I'm going to share my screen also. So screen sharing is allowed. So I can click on select one of the windows, and these are all pretty adjustable automatically. lay out the videos into the best possible scenario. These both users are connected now. I'm going to disconnect from the mobile and exit the meeting from the mobile. So you can see the user got disappeared from the mobile client. Stop the screen share and stop the video here. You can just close the tab and that will exit the call as well. One of the things that you can do here is instead of logging in, you can basically use a serverless mode where you don't have to log in by sending and receiving the negotiation for WebRTC using messaging like emails. So let me log out from here, and this option allows you to use email messages for call signaling. So the right part here allows you to capture the offer or answer negotiation message and send it via email. As an example for self-test, I'm going to just say some user saying kundan10@gmail.com and click on call. So it opens the email client, which I closed just now. But more importantly, it allows you to copy the signaling messages to the other side by sending an email. When the other side receives it, it pastes it in this area in the other side's own app. I'm going to do self-test, so I'm just going to paste it right here. As you can see, all the notifications behave as if you are communicating with the server, but this is a serverless mode. When I click on the call to answer, again it opened my email to send the response, but I'm just going to copy this and paste it here. So now the two calls are connected based on these two. Because it's not logged in, the usernames are not present. They're just some randomly generated values, and they behave as if they were connected using the server. So beyond this, all the parties, all the clients are basically controlling the conference using a peer-to-peer network. So in this example, if I do conference video, again it's doing the same set of messages using the peer-to-peer network. There is a test application that I have written which allows me to not only test that the peer-to-peer algorithm, peer-to-peer conference control among these different users, many number of users can work or not, but it also helps me to figure out how things behave when there is a disconnection in the network. So as an example, this one is just showing 8 users. You can change this from up to 30 users for testing. When I click on a user, say Alice and then Bob, internally it creates a connection between these two as if Alice called Bob, and the two of them get connected. So here these two are connected. Say Alice invited Carol also, and maybe Carol invited Dave. So all first 4 of them are connected. So if I send a message hello from the first user, it will go to this chat. Now let's say that Emma called Alice, she got connected. Henry called Frank, Grace called Henry. Now these 3 are connected in a call. Now if one of these users calls one of these users and they decide to merge the two conference, all of these will get merged. So let me show you how that works. Here these 3 are connected and these 5. So now say Carol invited Henry. in the same call. Now all 8 people are in the same call and they share the same messages. The messages which were sent in the first one get merged with the second one and so on. I can continue to chat from Carol, and let's say here from Grace. Now for some reason, suppose one of the links get broken. So for example, Alice to Carol connection gets broken for some reason. So the peer-to-peer network gets partitioned, which means that these 3 are connected and these other 5 are connected, as you can see in the user list as well as other places. So they can continue with their testing chats, like for example, when this person sends a message, Bob, it gets delivered to these conference with these 3 people. When Dave sends a message saying it gets delivered from these 5 people in the conference. Now, after some time, they figure out that somebody is not there, they got disconnected because of the user list and so on, and they decide to merge the call again. One of the users from this conference can call one of the users and they can merge. So as an example, say I can say Alice invited Henry, and the call got merged and all the messages again got synced. And this also supports the video call. So all these individual instances are actual web apps running inside an iframe. And if I enable a video call, say between Alice and say Carol and Dave and say one more user, Emma. So these 4 users are now connected in the video call, and I'm going to disconnect this link and they will get partitioned. So these 2 are now no longer connected, and if I connect again these 4 people will be connected to the video conference again. So let's say Frank invited Dave and those 4 got connected. You can also emulate a person leaving or getting disconnected. So for example, Frank got disconnected here. Once Frank got disconnected, a lot of people got disconnected because Frank was connected to 2 or 3 other people. And if Alice gets disconnected, for example, by clicking this, a lot of people will get disconnected again. But still, people who are in the conference already and they do not need connection with the disconnected link, they continue to talk to each other, Carol and Dave in this case. And they can reconnect the network again. So this is a test application that I use to emulate that the system works for different connections, reconnections, and is robust against people leaving the peer-to-peer network, people joining and merging the conference and so on, and be able to adjust the conference membership as well as the messages and the audio video state of the conference. So that is the presentation that I had planned. All the details are in this paper as well as on the GitHub website. So this is the GitHub project, which has the software which allows you to install the browser extension as well as host this on your own service if you like. That's all. Thank you.